Hey everyone, my name is Alex Zychek. I am a data scientist in the Department of Quantitative Health Sciences at Cleveland Clinic, and today we're going to talk about how we can build a toggle into your Shiny app to switch between traditional and chat-based data filters. We're going to look at this through a case study around the Hospital Readmissions Reduction Program. And so the HRRP is a federal program by the Center of Medicare and Medicaid Services that penalizes hospitals up to 3% of Medicare reimbursement for having excess readmissions in a few different disease cohorts like heart failure, COPD, acute myocardial infarction, and so on. So the key functionality I wanted to explore was, can we enable the user to switch between traditional data filters like select inputs or a natural language chat interface and kind of see similar reactive output downstream. So first, just looking at the app, it looks something like this. You can switch on chat mode. The user types in a query or a question, and then the app is going to update accordingly. And we can actually look at the live app right now. And so by default, we have these traditional like select input type filters on where we can go through different hospitals or cities and the maps are going to update accordingly, or we can focus on switching on different disease cohorts. And your typical manual filters, or we can switch on chat mode, and now we just get this prompt to enter a message, and I'm going to say, show me the top 10 hospitals with the most readmissions for heart failure. And so it's going to do some thinking, and then it ends up generating the SQL query. More on that later. Gives me a little response, but then you saw that it updated all my tables, my graphs, and my map, and now presumably I have these hospitals that have kind of the highest readmission penalty due to heart failure in the state of Wisconsin. So I briefly mentioned the SQL queries. So why did it write this? Well, what's really powering this app in the back end is this query chat R package. And so the conceptual flow of how this package works is the user asks a question, the LLM in the back end generates a SQL query based on the metadata of my data set that I fed into it, and then it returns the query, which is executed on your data set locally, at which point your data is filtered, and then it can be consumed by downstream reactive values like you normally would in a Shiny app. And so it provides a very clever way to manipulate data in your app through a natural language interface while really maintaining data security. Data is never actually leaving your app. The LLM only knows about the metadata in your app, and so it's a very clever way to kind of build a nice user experience with a chat interface without compromising any data leakage. So how does this actually look in the code? And the basic idea is in a global.r file, or kind of at the top of your app.r script, you would initialize a query chat object specifying your data source. In this case, I have like a curated master data set that contains all the data that powers the app. Choose a client, so this is your LLM provider, and you can just use the Elmer package, and in this case I'm using Google Gemini, where I have my API key stored as an environment variable, and then a little greeting depending on what you want your prompt to kind of show the user, and then a data description, which in this case is just a file I have in my app directory, and more on that later. So then in your user interface, you create this query chat UI object, which is going to give you the whole chat interface. And then in your server side, create this query chat server and feed it your configuration, and that's going to handle kind of all the back and forth between the LLM. And now I can access my data set through this df object in query chat, which is just going to store the data set most recently from the most recent query executed on the data set, and then I can just use that downstream like I would in with any kind of reactive data set. So what I found is the key to success in using query chat is really in this data description argument. This is where you can kind of feed the LLM a system prompt about your data set, about the metadata, and really give a thorough description about what all the columns mean, how to interpret a row of your data, different labels. And so this is what my data description file looks like for this app, and it really adds value to the user experience because this is what allows, for example, in my query, I typed heart failure out as words because that's kind of natural if I'm just typing a question. But in my data, heart failure is represented as HF, and it wouldn't necessarily just know that without me specifying. So this is where I can kind of give those instructions, which will allow it to write accurate SQL queries, but still giving the user the experience of being able to kind of just type in natural language. So back to that toggle, how did we make this part work? And very simply, we just use conditional panels. So in the UI.R file, we have an input switch from the bslib package, which is just going to let you switch between chat mode. And then all we do is have a conditional panel that if it's not in chat mode, just basically supply your traditional data filters. If it is in chat mode, supply this query chat user interface. And that's all you really need to do in the UI. And then on the server side, kind of similar conditional functionality. I just have a data set being stored that kind of represents whatever's being pulled from the traditional data filters sitting in the background. And then I have my query chat server object, and then my data set that actually feeds the visuals is just a reactive value that is conditional based on the state of the toggle. So if it's in chat mode, pull the result from query chat. If it's not in chat mode, just pull this temporary current hospital table, and now I can use my data set downstream, whichever source it came from. So in summary, the query chat package is what lets you build the chat interface and go back and forth between the LLM. And the key to making this work effectively is the data description argument for a better chat experience. And then we use the input switch to create the toggle with conditional panels to render just based on whatever is selected by the user. And then reactive objects on the server side help you determine what data set to pick up. And so kind of a rule of thumb here is to keep things upstream as much as possible if you're trying to do this, so that your visuals downstream, like the map I had and the tables and graphs, kind of can take a similar data structure, whether it's being processed by your traditional filters or processed through these SQL queries. Kind of design it in a way that you get a predictable output so you don't have to change anything downstream. So with that, I've added some links to the live app here, the source code, and a link to these slides, and thank you very much.